afternoon, everyone. The change happened because this work is also part of the Accord project, so it makes sense to have a continuation of the presentation. I will focus on the part of the project where we used artificial intelligence. So again, the work is part of the Accord project, and in this image that Rita just demonstrated, I will be focusing only on the interpretation of regulations. So there were the two streamlines, and I will be focusing on just how we use artificial intelligence in order to interpret the regulations and to generate some regulations that are, or rules that are machine readable and processable. In order to achieve this automation, the project has created a framework, and part of the framework and part of it is also how do we make these regulations machine executable. And the focus for us has been using semantic web technologies and artificial intelligence, so a combination of both. We did a lot of work in ontologies as well, and I presented this work in the workshop this morning, where we designed and developed the AC3PO ontology. And then the plan was to use this also as a basis for our natural language processing. Now, I asked ChatGPT to create an image for me that will combine AI, natural language processing, and large language models, because there are two approaches that I would like to introduce to you today that we followed in the project. One is what I would call the traditional natural language processing, and the second approach, which we happen to know during the life of the project, using these large language models. This is the methodology that we designed in order to interpret the regulations. The first pathway is the manual one. We're using this race methodology. An expert will manually annotate the text and so on and so forth. The second approach will be using a natural language processing, and then the third approach will be the hybrid one, but in our case has been replaced with a large language model approach. Now, in order to achieve the interpretation using large NLP, it's not a straightforward process. It has been very challenging, and even when I proposed the task at the beginning, everyone, or 4 years ago, everyone was saying, what is this? You cannot do this with NLP. Again, the basis started with the ontology so that we can understand more about what we are doing, and then we designed the NLP pipeline. So how will we go from a document, and then how we will end up with a repository of rules that are machine readable and executable. There is some work in between. So first we need to extract the sentences from this document. Then we need to do some information extraction, which is the named entity recognition, where we use the ontology in this part of it. Then we need some post-processing of these rules until we reach the rule generation. And if I start splitting all these boxes, there are so many models, artificial intelligence models, that we need to develop for each of these pieces. So we need something to find sentences, we need something to classify sentences, we need something to identify very small entities, like this entity recognition component that you see in there. And if you see by example, this is how this NLP would work, that it will have, for example, a sentence, and we will have a graph that is this semantic-based rule being interpreted. Now, the first struggle kicked in where no data set was available. We have invested like 20 or more human resources in order to annotate sentences. And in these 20 resources, very humbly, there have been so many professors, because it was also a very challenging task to interpret them. So it was not just identifying relations and entities in a sentence, but how do you interpret it in the right way? We managed to create 1,000 sentences being annotated. These sentences are out there, available to be reused by all of you. And we managed to achieve very small achievement, I would say, compared to large language model, where we can go from a sentence which is an English sentence to a graph representation of the sentence, but interpreted in a meaningful way by an expert, not just connecting dots. In my slides, I have included all the GitHub resources and papers that you can make use of what we have produced. Again, the journey was quite challenging, and these are all the AI work done, evaluating the output, making sure that we have the right accuracy and precisions. For everything, there has been an AI model behind every small task. Then we had the large language models. And we started to also experiment, of course, with the large language models. In this case, it will be quite more straightforward. We give the document and we take as an output these rules being interpreted automatically. Of course, there is a lot of contribution from our end, even using large language models, not only in testing every LLM that was out there, but the fact that we have been using approaches like few-shot learning or by refining large language models with a data set of 25 regulations being generated manually using the building compliance rule, a language that Rita mentioned. So using BCRL, we produced initially manually 25 documents, and we use those as few shots. So as a way to make the LLM operate better for our task. This timer. Okay, now another focus that I wanted to have for my presentation is not only to demonstrate and to share with you all the resources that we have produced, one approach using the traditional NLP, if I may call it like this, and you have the data set and you have some tools that you can generate this graph. A second tool is using the large language model. But another point that I want to make and that I care a lot about is how responsibly are we doing everything that we are doing, and how can we trust everything that we are producing. We are trying to make sure that we make some contribution to that. From our approaches, and well known is that with the first approach, which was very hard, we have not achieved so much as we can achieve with LLM. We still have some ground truth, and we have some metrics is that we can say that this rule has been interpreted with this level of accuracy. With the large language models, the only thing that we were able to do is to have the human in the loop approach, which means if I go back to the previous slide, in the tool you have this content that has been generated, and as an expert you have the chance to double check it and to approve it, to approve its interpretation before it is pushed into this repository of rules. But there is still more to be done in this regards, and my personal take on this is that we should go for what is called the neurosymbolic AI, where we are combining ontologies and all this structured data and all these models that we can trust with AI. So really a neurosymbolic approach where we are combining semantic web technologies with the AI part of it. There are other works that we continue to do, even with large language model and with these RAG approaches, how can we interact directly with IFC, and how we can also do checks with that. But in terms of the interpretation, these are the main outcomes. So an AI tool that either provides you intermediate outcomes using the NLP and telling you this is the percentage of how accurate you are standing here, and it's your choice to move forward. Or the LLM part, where again with a human in the loop approach, you can double check the outcome and then you can approve that interpretation or not. And I made it in 10 minutes. Thank you very much.